So this is page number 69 in your notes book. Right, so let me just write the page number up here. All right, so this is page 69. So I gave you these notes in class for average atomic mass. So remember that this is the formula that is not on reference table T. And you basically need to remember this formula. And it basically should make you mad that there is no formula on table T. So MAD stands for multiply, add, and divide by 100. Right, so we're going to have to multiply our percent, right? So like in this case, 75% times the mass, which is 133. Then we would add 20% times this mass of 132. And then we would add 5% times the mass of 134. So notice how here, these percentages are written as a decimal, right? Which takes care of the dividing by 100. So let's get right to our examples. So if 80% of iodine has a mass of 127, so then I would do 0.80 times the mass of 127. Now I want to add that I have now 17%, right, which is 0.17 times the mass of 126. And then I have 0.03% times the mass of 128. Hold on one second, let me get my answer key. Okay. So when you multiply those numbers and then you add them up together, you will get an answer of something as soon as I look it up in my book here. And I should have been more prepared. I should have had this already open. You're going to get 126 and 0.86. And that's atomic mass units is our unit. All right, so if I have a sample of gold, 50% of gold is an isotope mass of 197. The other 50% has an isotope mass of 198. So remember, MAD, multiply, add, divide by 100. The divide by 100 is we make our percentage a decimal. So I have my 0.50 has a mass of 197. And then I'm going to add my other 50%, right? So my other 0.5, which has a mass of 198. So then when I multiply those two numbers, I get a number. I multiply and get a number. I add those two together. That's going to be 197.5 atomic mass units. All right, let's go on to our next question, question number 3. All right, so we have 15% of the sample of iron is a mass of 55, right? So that is an isotope with a mass of 55. Remember, isotopes have a different number of neutrons, so they have a different mass, but they're still the same element identity-wise. So I'm going to do my 15%, right? So 0.15 has a mass of 55. So there's my multiply and my divide by 100. Now I'm going to add my 0.85 and times the mass of 56. So then when I do this math, I come out to be 55.85 atomic mass units, right? So this is the average mass of these two isotopes together. Remember, it's a weighted average because the sample has different percentages of the different mass numbers. All right, so here I have 99% of hydrogen has a mass of 1, right? So percent times mass, right? 99% has a mass of 1. Now I have to add, I have 0.8%, move the decimal point 2 places to the left. So that's 0.008. Am I right? Yes. 0.0808, sorry, 0.008% of hydrogen has a mass of 2, right? So then that hydrogen's got more neutrons, right? So that's what makes it heavier. And now I have 0.2% of hydrogen has a mass of 3. So then that's going to be 0.002 times the mass of 3. So when I add all of those up together, it comes out to be 1.012 atomic mass units. right? So does that number make number sense? Yes, 99% of all hydrogen atoms have a mass of 1. So it does make sense that my number is closer to 1. All right, so let's look at question number 5. All right, so question number 5, 95%, right? So percent times mass. So 95% of this sample of nitrogen has a mass of 14. Now 3%, right? So that is 0.03, has a mass of 15. And now 0.02, right, which is our 2% of the nitrogen, has a mass of 16. So when you add those all up together, you're going to end up with a 14.07 atomic mass units. And ask yourself, does it make number sense? Yes, if 95% of nitrogen has a mass of 14, my average is going to come out to be closer to 14 because it's a weighted average. All right, so then now I have 0.98% and of carbon has a mass of 12. And now if 98% has a mass of 12, right, I should have a mass number closer to 12 than to 14. And I only have 2%, right, 0.02, has a mass of 14. So when I multiply and add those together, I'm going to get an average atomic mass of 12.04 atomic mass units, which again looks very close to the atomic mass of 12, which 98%. All right, so this is how you do the average atomic mass formula. Let's go back up to the top, right? So here we have multiply, add, divide by 100, right? So we take our percentage times our mass, and we take the next isotope percentage times mass. And we keep doing that, however many isotopes we have. And don't forget, divide by 100. When you made your percent a decimal, that takes care of the divide by 100. You don't divide by 100 twice. Making a percentage a decimal is dividing by 100 already. All right, thank you. And until our next video, look forward to seeing you next time.